Now, I want to go over these fuel pumps to give some of you an idea of what the parts and supply chain logistics some of us would have to go through if we really want to keep some of our vehicles that are 20 years out of production roadworthy. And some of the most critical and often overlooked components are the fuel pumps. Okay, so what I have here on my right is, well, this is the OEM fuel pump assembly that was installed on my vehicle. And I went ahead and took some parts off of it for ease of illustration. And this looks, well, identical to the OEM fuel pump assembly. Now, I went ahead and painted this black because I had some corrosion issues. And I welded a little screw here as an alternate grounding point for the line that goes to the fuel filter to ground it, because there was some corrosion around the collar of the fuel tank. And so while I was doing an underbody restoration on the vehicle, that required me to remove the fuel tank. And while I had an opportunity to work on the fuel tank while it was out and address some issues, I wanted to make sure I had a good fuel pump in the assembly. Now, I didn't have to do this. I'm fortunate to have a fuel tank that has the 4.5-inch flange. Now, the fuel capacity of that tank is only 14.5 gallons, but because the flange is small, it could literally be pulled out of the service port that's underneath the rear passenger seat. And if you needed to change a fuel pump in my model vehicle, my model year vehicle, you can do so in under 5 minutes. It's literally that quick. If you have the updated fuel tank capacity, that's between 15 and 16 gallons with the 6-inch flange, that's too big to pull out through the service port, and so you wouldn't be able to do it that way. You would have to drop the tank in order to change the fuel pump, or cut the service hole bigger to pull the fuel tank out. And so it's a lot harder for those model year vehicles. So this isn't something that I had to do. I just wanted to do it to make sure I had a good fuel pump. And so what I did was I got this precision fuel pump assembly. And these are made by Ozark Automotive, and they distribute a lot of parts for O'Reilly's. And this is the fuel pump that I wanted to go ahead and install on my assembly here. And while I was doing so, well, it actually has this soft metal neck here, which I kind of like, but it's really sharp here, not to my fingers, but to the seal. And when I installed it, I ended up actually cutting a portion of that seal. I'm wondering if you could see that. Oh, yep, it's kind of there. And it took out a nice dish-shaped portion of that seal. And I could see it after I installed it. And when I saw that, I'm thinking, oh, nuts. I knew that while this pump was operating generating pressure, what would happen with that seal broken is that fuel would just shoot back out through this collar here, back into the gas tank. And what that would result in is, low pressure to the injector rails. So I thought, okay, I need to get a new assembly. And so what I did was I started looking around, and of course I turned to eBay. Not usually the first choice I go to, but they're a good source every now and then. And I saw this fuel pump assembly. It didn't look like this. The description was accurate. It was a CarQuest fuel pump assembly, and the price was right. It was under $22. So here's a fuel pump for the Contour Mystique. It's being sold on eBay. And it comes at a fairly decent price of $21.40 a piece. And if you look at the canned picture that they're showing, it certainly looks like OEM. But when I bought it, it looks like that. Not quite OEM. But they were using a canned image, a canned picture, a stock photo that looked like this. The OEM fuel pump assembly I was looking for. Now, I did ask the seller some questions to see if they could provide actual pictures of the item that we're selling, and they were quite cagey of wanting to do that. And I understood the reason why is because they were not in physical possession of the fuel pump. They were practicing a common technique known as drop shipping, where a seller online or mail order, they don't warehouse the components They're just sellers, and they're connecting buyers to the items that the buyers need to purchase. And so when they get an order, they simply tell the distributor or the factory to ship this part to the buyer. And so when I got the part, doesn't look like the OEM part at all. But so long as it's form, fit, and function, it ought to work. The question is it really form, fit, and function to the standards and specifications of OEM? And typically in the nuance, no, it isn't. So the first thing I noticed, the first thing I noticed, it came in this box. And in this box, this is the inner box. The outer box was a shipping container. No, it's packed really well. So I'm sure it was well protected. And the box looks intact. So it probably sat in a warehouse for over 20 years. It was probably manufactured in the late 90s, and it seemed to weather okay. But I did notice that this fuel pump doesn't really fit all that well. In fact, it's so loose that you could just pull it off like that. And I wasn't too happy about this, because I'm thinking, okay, if it's this easy to dislodge to come out, when you put fuel pressure in here, that could just easily push this thing out during operation. And I'm like, all right. And the reason why is because this fuel pump, the upper body here is actually shorter than the OEM fuel pump. And so it doesn't make contact all the way up through the seal. So I thought, okay, well, maybe I could I got a bracket here with a nut. I could maybe adjust that a little bit. Maybe I could just push this up a bit and then hold it down. Well, if I do that, I'm actually raising the inlet up about maybe a half an inch. And since this is suspended from the top of the fuel tank, raising this up a half an inch means there's going to be about a half to 3/4 of a gallon of fuel I will no longer have access to, because the inlet is higher than the lower bottom of the fuel tank. So I thought, oh, okay, well, how about if I go the other way and force it downwards into the bracket? And so my solution was to use these hose pieces and stick that in between there to force this to be more secure, so this thing wouldn't become dislodged during operation. And these pieces, well, these are rated for gasoline, so this isn't the type of hose that would deteriorate if submersed in fuel, and that's very important if you're going to do something like this. But the whole point is that the customer shouldn't have to do something like this for a part that they're just purchasing and installing. And nevertheless, this is typical for a aftermarket part. Okay, so I did a little bit more research, and I found this part being offered through Ford Parts Giant, and this was actually at a really good price. It was less than $6, believe it or not. And this is OEM. This is a certified Ford part. A genuine Ford sender and pump assembly for $5.82. Wow! And this is for the 98 Ford Contour. FordPartsGiant.com. And here it is. And it comes in a Ford box. And again, this isn't the box that was the outer box. It's the inner box. They had a good shipping container, so this is well protected. But if you look at the box, okay, September 24th, 1999. Wow. So it's been sitting in this box for presumably, well, about 24 years. Got some holes in it. Wow, what happened here? So imagine this sitting on a shelf somewhere in a warehouse, probably getting shifted around, moved around, bumped around over the decades. You know, maybe it was even knocked over at some time. They got bubble wrap surrounding it. But if you look closely, you'll notice something is a bit off. Well, okay, so this is what it looks like. And here's this assembly. Okay, so it's bent a little bit. I don't know if you can see that. This fuel pump is bent toward this way, and if you look at the sender assembly, this isn't straight. Okay, in fact, it gets stuck right about there, and the sender, okay, hold it up side by side here. Okay, that's on pretty square, and this guy is bent. Okay, so what happened? Well, I mean, yeah, this box could have gotten dropped and could have impacted here at some point in time. Maybe here, perhaps. And that might have bent it a bit. So I'm going to have to do some MacGyvering even on an OEM part to get this straight and to get this working to where it's sending accurate fuel level information back to the gauges. But even so, that's not the most important part either. The most important part are the pumps themselves. Okay, so let me get into this in a bit. Okay, a little introduction on how these fuel pumps work. The fuel pump unit is basically a DC electric motor which drives an impeller. The impeller pump picks up fuel from the gas tank and sends it to the top, which is connected to a fuel line, which then carries the gas forward to the engine compartment. Now these parts here are what typically make up a DC motor, a submersible in-tank fuel pump unit. And I pulled this thing out of a 2004 Mustang, which had roughly 135,000 miles on it. This is an OEM fuel pump. And when I pulled out the pump, it was a working unit at the time, but it's been sitting around my garage for a couple of years. So I went ahead and decided to cut it open so you could see the parts here that make up the fuel pump. And aside from some light oxidation that's around this laminated steel that make up the armature, other than that, this fuel pump was perfectly fine. And incidentally, if you should ever pull a fuel pump from a vehicle that you know you're going to reuse, but you're going to just keep it out of service for a while, it's a good idea to go ahead and spray some of that stable fogging oil and spray about half a teaspoon into that. And you're going to need some patience. It's going to take a little while for that to get in there. But yeah, about a half a teaspoon, and then kind of shake it up. And then that should lubricate the armature to prevent that from corroding. Make sure you get all the gas out of this before you apply the lubricant. Kind of shake all the gas out and give it a day or two to dry. And the fogging oil will keep the rust from forming. Not that this is bad, it isn't, but any chance you get to keep rust from forming in the fuel system, you should do it. And then once you've done that, then just go ahead and seal this in a Ziploc bag and keep it out of moisture. So starting from the pieces here along the right, these three pieces make up the impeller housing, which comprises of a front end cap with an entry port and a center load bearing. Next is this solid plastic impeller with the micro vanes along the circumference. And the rear housing plate, which has the exit port and the sleeve bearing for the motor shaft. So the motor shaft is secured by the end plate, and there's a keyway on the shaft for the impeller to fit through. So, and then this would rotate clockwise. Now this impeller assembly, this makes up the pump proper. So this works by transferring fuel. It's picked up through the inlet port where it enters this loading cavity. There's a mirror image on this side. And when the fuel is in that loading cavity, when the pump is in operation and the impeller is spinning, the vanes, it forces and carries the fuel to travel along the arc or the circumference of the chamber in which case the centrifugal force builds up pressure to a static point. And there, at the end, that force then drives the fuel out through the exit port and into the motor assembly. And so the combination of the high RPM of the impeller and the general uncompressible property of liquids results in a pretty efficient high volumetric capacity pump. So this arrangement can move a lot of fuel in a short amount of time. The armature assembly consists of 8 pole windings that are encased and sealed in this polymer jacket. The coils that are wound internally around the poles, the coil wire insulation is made out of an enamel that's not resistant to gasoline. So if the coil wires were exposed in direct contact with the fuel, the insulation would dissolve and the coil wires would short themselves out, and that would lead to motor failure. So to prevent that from happening, this layer of polymer plastic is encasing the whole internal coils so it never makes contact with the gasoline. Now these laminated steel plates that you do see, these are the poles themselves, and these are left exposed for a couple of reasons. And the first is the general motor design principle that in order to maximize the flux intensity interaction along the induction plane made by the magnets here, okay, the distance between the stator poles and the armature poles are kept minimized. So any inactive material that's not either part of the magnet or part of the armature poles, if it would anyway increases the distance between the two, that's reduced as much as possible. And this is done to maximize the torque potential of the motor. And the second reason is to maintain thermal conductivity with the fluid media that travels around the armature to carry away heat and keep the motor cool. And so this is a basic design principle and requirement of this motor, where the fuel being pumped is also used to transfer heat away from the motor, and that is the only method that these fuel pumps have to keep themselves cool. I don't know if you can see this, but there are various material cutouts along some of these poles, and this is done during assembly, and this is how they fine-tune the balance of this armature assembly to minimize any type of vibration during operations. And so the lower the vibrations, the longer the bearing life will be. So this here is the central motor housing, and it's essentially a cylindrical tube. And that's, you see that step in there, it's thick on the inside and has thinner walls along the ends. And the thick walls here, that's where the magnets rest against. And so these thick walls, they provide rigidity and maintain the position of the stator, the magnets. And the thinner walls here, that affords ease of manufacturing when the pieces are put together and the machine crimps both ends. And it makes a very self-contained sealed unit. Now, to take this apart, I had to take a Dremel with a reinforced cutoff wheel, and I essentially cut off the crimping on both ends. And then I also had to make this lateral cut to relieve the pressure as the parts they're pressed in. And that's how I was able to disassemble these parts. And this is how it comes together.
This middle piece acts as a spacer. And you have the end cap, which also has a spacer to keep the magnets apart. And let's see if you can see that in there. And the armature fits in like so. And the rear plate. And then the impeller. And then finally the front end cap. And so as fuel is traveling through the motor assembly, it goes down these passageways and around the armature. And as we get to the end, we have this insulated plastic end cap that contains the contact brushes, the rear sleeve bearing, and the, so you can see that there. This is the outlet port. And there's a one-way check valve so that fuel that exits the pump only goes towards the engine compartment and not back towards the pump. Okay, now during operation, fuel surrounds the brush and commutator assemblies as it's running its way through the pump, and that provides lubrication and arc suppression for the contacts. In brushed DC motors, the arcs normally occur because the armature coils, that's an inductive load whose transient voltage can get rather high when the action of commutation breaks electrical contact along the plane of inductance. Okay, but, well, since we're operating this in a fuel tank and we generally don't want loose sparks flying around, okay, the motor is completely sealed and encapsulated, so it can use the gas to essentially put out the fire, so to speak. Okay, so the fuel acts as a dielectric, and that prevents most of the arcs from forming. And with the arc suppressed, there's a reduction in the pits and micro welds in the brush and contacts, so there's less abrasion to wear the components down. The lubrication also helps minimize any wear, and any incidental arcs that do occur, they're pretty small, and they're effectively surrounded by fuel without any air or oxygen for combustion to occur. So if you figure that this pump has been operating since 2004 all the way to about 2017-ish, and it's got about 135,000 miles on it, the contacts at the end only touch the middle portion. The brush has only touched the middle portion of the commutator contacts on the armature, and you can see there's not a whole lot of wear in the middle. And the brushes here, they've also got some pretty good distance. You know, there's a lot of life in these brushes. And so if this pump was still together, this thing could probably go on for another 100,000 miles or so. Yeah, easy. So the way Ford OEM spec'd their pumps and had it constructed, that's doing a very good, robust job. So when the pumps are finally assembled and it's put together, the manufacturer includes an assembly lube. And the purpose of the assembly lube is to provide just enough protection for the fuel pump while it's in storage. Once the pump has been installed and it's initially used, the fuel washes out the assembly lube. And then from then on out, it's the job of the fuel to provide lubrication for the pump.
And that brings me to the final point that I want to bring up about these new old stock fuel pumps. The assembly lube is great to help prevent oxidation, but if it's been sitting on the shelf for a long time, like in these two cases, several decades, that assembly lube can dry out and it can leave a coating of hard varnish on the brush contacts. And that will impede the flow of current through the motor, and sometimes even enough that it won't even spin. But fortunately, before we install these fuel pumps, we can actually test for that and try to fix it. And if these fuel pumps have been sitting on the shelf for a long time, we should test for it. Okay, so let me use this pump that we disassembled as an example. I'll go ahead and test for the continuity. Okay, that's a beep. Okay, I'm getting good continuity through there. If I test the DC resistance, not the AC impedance, but the DC resistance, I can even read the ohms. And it looks like I'm getting right around two-ish ohms. And so what I'm testing, let's take this apart again. So I'm testing the current as it's flowing through these contacts, through the coils in the armature. And it should be really low, like what you saw there. Okay, now let me go to this new fuel pump made by Precision. We see here, this is copyright 2020. So I'm reasonably certain that this pump was manufactured in the last several years. And so the DC resistance should be really low. And that is, the lube in there shouldn't have dried out by now. I mean, it's still relatively fresh. So let's go ahead and test that. I'm going to put this back on continuity. As a bell. Measure the DC resistance. I'm getting, wow, less than 1 ohm, almost 0. How much if I just bring the contacts together? Yeah. So that tells me that this pump is good to go. If I had an application that required the use of this pump, I wouldn't hesitate to install this. This thing is ready to go out of the gate, and it shouldn't let me down. Okay, now what about these two pumps that have been sitting on the shelf for several decades? Well, if I measure the resistance here, okay, so that's these two contacts. Actually, let me put that on continuity. Right. And if I try to measure that, okay, I do get a bell. And if I measure the resistance, all right, so about 32 ohms, and that is kind of high. Okay, so when I first got this fuel pump and I did the measurement, the resistance on this guy was actually north of 300 ohms. And I knew then that that was just way too high for this pump to start. And so I had to do something to get the resistance lower. So yes, that's right. So aside from the fact that this was loose, and I knew it would just come off if I tried to install it, this pump was essentially DOA when I got it. And I had to do something to correct that, and I'll show you that in a bit. Now let's test this Ford OEM pump. Put it back on continuity. Sometimes it'll work, sometimes it doesn't. It's a little cheap motor, cheap meter. Get the nice little bell. Switch to DC resistance. And we're getting, okay, so 7-ish ohms. Now that's still pretty high. I mean, anything compared to 1 or 0, that's pretty high. But that's still low enough where I feel pretty confident that I can just go ahead and stick this in the fuel tank, connect it up, and it'll just go ahead and function. And the reason why is because when Ford had their fuel pumps made, they spec'd a higher grade, higher quality lube, one that's more shelf stable. And all I have to do is, I think I'm just going to just rebend this assembly back and then just stick it in and fill it with gas and start it. And I'll do a video about the first starting of the Contour, and if there's any issue, you guys will know when I do, or at least you guys know when I release the video. And if there's any issues, then we can go through some mitigation steps. But I don't believe that's going to be the case. I think this pump is good to go. It's a good pump. Okay, so let's talk about what I did with this guy.
Remember when I mentioned earlier that if you pull a working fuel pump out of a vehicle and you know you're going to use that pump again later, but it's going to be out of service for a while, to go ahead and put some fogging oil in it to avoid oxidation? Well, to revive a fuel pump that has varnished contacts, I'm going to do something similar to that, but instead of using fogging oil, I'm going to use this deoxit contact cleaner. And to do that, I'm going to have to go ahead and remove this fuel pump and spray some contact cleaner down the inlet port, and then I'm going to have to work the impeller with a soft wooden or plastic toothpick to get the impeller to turn, to get the motor assembly to turn, to clean out those contacts. Okay, so I'm going to go ahead and do that. And pry out the strainer here. And let's see if we can see the impeller. All right, looks like I'm gonna have to turn the camera light on. See if I can do that. All right, so you can see the impeller in there. I'm gonna go ahead and just spray some contact cleaner down there. All right, now I'm going to try to turn the whole motor assembly using this plastic toothpick. what I want to do is I want to get this impeller to turn at least one revolution so that all the contacts will be cleaned. I don't even see that spinning there. Let's see, all right. And I'm getting better success here using the wooden toothpick. And since this is a plastic impeller, avoid using anything metal down there to turn this impeller because you don't want to break the vanes. No, that's still not stiff enough. All right, I think that's about one revolution.
Okay. Sorry my camera kept cutting out there, but anyway, I got the contact cleaner in here and turning that impeller with a wooden toothpick, and I got it down at least one revolution. So now that I've done that, I want to go ahead and retest the DC resistance I get here. So I'll turn this guy back on. Put it on the DC resistance. And how many ohms do we get this time? And we're down to, all right, 6 ohms. That's a bit better. Still a little bit high, compared to 1, but I'm pretty confident now that if I were to stick this thing in now, today, this would work. And then the fuel would wash out all the contact cleaner and all the varnished assembly lube, and maybe after a couple hours of use, this thing would, should be just fine. All right. So that is an example of what we have to deal with, whether it's aftermarket, OEM, new old stock, aftermarket, for some of the pumps that have been sitting around on the shelf. We're always going to have some type of issues, even if it's OEM. Maybe it doesn't quite fit for aftermarket. And this is, just we just have to deal with this. If we want to keep our old cars on the road, it's essentially, it befalls to us. It's our responsibility to, do what we have to do to make these things work in order to, get our rides going. And, well, yeah, that's it for now. So, yep. See you guys. Oh, yeah. Well, let me just put this back together. Funny that this fuel strainer has to go on first before the rubber mount. Put these on. All right. Should be enough still in there to make a seal. All right, now that's on here, nice and firm. So, assuming there was still enough length of neck to make a good seal here, this should produce adequate fuel pressure if I ever needed to use this pump. Again, I don't think I will use this pump. I'm going to go ahead and use the OEM one after I bend this out. But I'm going to leave that for the other tank video.